this video, we're going to talk about basic integration or antiderivatives. These can be very difficult and challenging in the beginning. However, I'm hoping that what I show you in this video is going to be kind of an easy way to remember how to do them and a quick and easy way for us to figure out how to solve really any basic non-substitution integral. So I've got a bunch of different kinds in here and hoping to just make it a little bit easier for you. So basically, once we take the integral, this is probably not the best example per se, but I mean, once you take the integral of, say, a derivative, you're going to get back the function, obviously plus a constant, because the moment you take the derivative of any constant, it goes away. So we always write back in this plus c. That plus c represents any constant that may have disappeared throughout the problem. And depending upon what the question is for integration, we can find that plus c. But that's for another video for you to check out later. So let's just jump right in. If I wanted to take the integral of this expression here, it's very simple. I like to think of this as kind of a reverse power rule. So when I think about it that way, how did we go from a specific expression to give me 8x squared? Well, the place I always start with integration is always in the power. Basically, what I want to do is I want to go backwards, right? It's an antiderivative. We are undoing that derivative with an integral. And so what happened was we have our function, and that power we raise to a power of 1. It takes it back up to the power of 1. But when we do that, I have to divide my constant by whatever the power now is. So when I have that, let's say that I had just this problem here. If I took the derivative of 8 over 3x cubed, well, it's just a power rule problem, right? Bring the power down. That gives me 24 over 3x squared. This would simplify, giving me 8x squared. So again, I always want to start right here with my power. I want to raise that power up by 1, and then I'm going to divide my coefficient by whatever I raised, whatever the new power became. So all of that chicken scratch gone. What I have is we have 8 over 3x cubed. When I look at this term, I have minus. Well, that power is clearly 1, so I'm going to raise that power back up 1. So I have 4 over 2x squared plus 2. And these are the easy ones. The moment you have just a constant, we put our variable back in. And finally, we always add in that plus c to represent any constant that may have disappeared. Go ahead and simplify your problem if we can. Obviously, this will simplify here to give us 2x squared plus 2x plus c. And that is it. All right, so let's try another one. This one's a good one. This one involves us having a trig function as a part of it. However, excuse me, we also have what we have is a fraction as a coefficient. So I'm going to show you how to do this one as well. So when looking at this problem, we obviously know that how do you get cosine when we take a derivative? Well, we've taken the derivative of sine. So kind of going backwards, the integral of cosine x is going to be sine x. So then we have plus 4 over 3x. Well, think, what is our power doing? Our power is increasing by 1. That goes to 5, and that means we have to divide our coefficient by 5. So when I simplify this, obviously we have our plus c as well. When I simplify this problem, I have sine x plus, well, now we have two fractions, so I have 4/3 divided by 5. Well, that old school 8th grade trick, keep it, switch it, and then flip it, right? So now I have 4 over 15 x to the 5th power plus c. That would be my final answer. And so again, if something like that is confusing to you, maybe I want to check myself. Well, the derivative of sine of x gives me cosine of x. The derivative of this term, well, that 5 comes down. 5 times 4 gives me 20 over 15, x to the fourth. Any constant will disappear, so that's gone. I simplify my fraction here. Well, that's 4/3 x to the fourth. So I know that I am correct. So a nice, quick, and easy way for us to simplify and check ourselves. Hopefully that makes a lot of sense. But let's keep trying some, because I've got some pretty interesting ones here as well. So again, when I see a problem like this, I want to simplify a little bit to begin with. So I'm going to rewrite my integral as x to the 1/2 plus 1/3 x to the negative 1/2. All right, we should feel comfortable with the switch of this coming into the numerator by changing the power. And again, all of that is taking the derivative with respect to x. So now I'm going to break this down to make it a little bit more understanding, but it'll take a second. Remember, I'm looking at increasing my powers by 1. Well, if I increase 1/2 by 1, I know that that is basically adding 2 over 2. So that gives me 3/2. So my power is now x to the 3/2. My coefficient is 1, and we are dividing that by 3/2. Plus, I have 1/3 x. Well, got to add 1 here, so negative 1/2 plus 1, or 2 over 2, gives me a positive 1/2. And so I divide my coefficient by whatever the new power is. Go ahead and simplify these two. Well, keep it, switch it, and flip it, and you wind up with 2/3 x to the 3/2 plus, keep it, switch it, flip it here, we wind up with 2/3 x to the 1/2 power plus c. And there we go. So even dealing with the fractions, hopefully it's not as bad as it looks. Let's do one more here. When we have fractional exponents, again, sometimes it looks like it can be pretty tough, but I'm hoping that this will make a little bit more sense. So I'm going to break it down again. I have 12x. Well, I need to know what this power is increasing to. So 3/4 plus, well, 4 over 4 also is 1. That gives me 7/4. So I'm going to divide my coefficient by 7/4. X increases to the 7/4 power minus 9x. Well, my power is increasing by 1, so 5/3 plus 3 over 3 gives me 8/3. So divide your coefficient by what the new power is, x to the 8/3. And we have that plus c. Simplify our problem. I now have 12x. Whoops, I'm sorry. We have, keep it, switch it, flip it. I'm going to wind up with 4 times 12x over 7. And that x is to the 7/4 power minus 3 times 9 over 8. X to the 8/3 power plus c. Keep simplifying. I have 48x to the 7/4 over 7 minus 27 over 8 x to the 8/3 plus c. And so you can always check yourself by taking the derivative again. It's an easy way. They're fast most of the time to figure out how these basic integrals work. So I hope this video made some sense. Please check out the other videos on integration if you have more questions. But thanks for checking out the video. I'll see you next time.